Today we're going to tackle the variance of sampling distribution. But before we start, please make sure to subscribe and like the video for more updates. Now, what is the variance of a sampling distribution? The variance of a sampling distribution measures how much a sample statistic fluctuates from sample to sample. It tells us how much value we can expect from a sample estimate to vary from sample to sample if we repeatedly take random sampling from the same population. Now you might wonder, what is the importance of a variance of sample distribution? Why should we study it? Well, it is easy. It can be used for your future studies. It is because the variance of sampling distribution helps us in terms of calculating the population that you are going to select in your research. Especially, the variance of sampling distribution will be helpful for senior high school students and for the college students. That is why we need to study it. Now let us move on to how to get the variance of a sampling distribution. We are going to use the formula sigma squared is equal to the summation of sample mean minus mean of the sampling distribution to the power of 2 over n. But if we're going to consider the Bessel's correction, we should use, instead of over n, we're going to use n minus 1. This is because it corrects the bias from the estimates of the population. Now let me give you an example. There are 10 balls numbered 2, 4, 7, 8, 9, 11, 13, 15, 16, and 19. Consider all possible sample size of 5 which can be drawn with replacement from the population. Find the variance of sampling distribution. As a reminder, if you still haven't watched the video about the mean of the sampling distribution, I recommend that you watch it since we are going to use the knowledge so that we'll be able to put the correct value in our formula to get the variance of a sampling distribution. Now the first step that we are going to do is to find the mean of a sampling distribution using the formula of mu is equals to the sample mean over the number of observation. We're going to substitute them.
Now that we have all the values needed, we're going to solve for the n, or the number of observation, by using the formula NCR is equals to the n factorial over n minus r factorial and r factorial. After that, we're going to substitute it into the formula of the mean of a sampling distribution. After we solve for the mean of a sample distribution, we're going to proceed to the variance of a sampling distribution. Just substitute the values, then simplify. Now you might notice that I did not put the value of the sample mean in the formula. This is because there are 252 sample mean, and if we include them all, it'll probably take a while.
Since our variance of sampling distribution is 0, this would mean that our standard error is also 0. We can conclude that there is no variability and the sample error is not present in the problem. This thus resulting to identical results since our samples provide a perfect uniform. That's all for our discussion today. I hope that you've learned something and thank you for watching.